Hello, everyone, and welcome to today's free public webinar with TPC Training entitled The Systematic Approach to Troubleshooting. My name is Ryan Smith, Product Manager and Instructor here with TPC Training, and I'm going to walk you through just a little bit of what TPC calls our systematic approach to troubleshooting. And what that means is for any job, any role, any type of problem-solving kind of activity you're trying to do, it's good to have a systematic way of going through it. So a way that you can follow each and every time for any sort of issue you might face out there on the job. Again, our company is really a total training solution in the sense of technical, electrical, mechanical maintenance, and operator training. So that's really the focus kind of we bring to the mix in this session. But really, any job, whether it be even, just fixing your tire or an IT computer related issue or something at home or something, but even between people, the troubleshooting approach can really help get you from one point to the next and get the issue solved quickly. So before we get into the meat and potatoes of today's chat, where we talk about this approach, I'd like to just let everyone know here that this session is being recorded and it is live. So this recording is going to be posted onto our TPC website within 2 business days of today's session. And also, since this session is live, I want you to feel free to use the Q&A feature of this session freely and openly, and I'll be able to take your questions at the end and see how many great Q&A discussions we can have on this session. So you should see on your toolbar, there's a bunch of options down there, but the one you want to pay attention to is Q&A, the Q&A button. If you click there and type your question, it's going to come straight to me and I'll be able to help answer some of your questions during this event. Now, I also want to let you all know that the PDF of these slides you're going to see here are going to be available as well, along with the recording on our website. So keep a lookout for that. We'll be sending you an email with that recording after this event. So I think the first thing we want to do is get into a little poll. I'd like to learn a little bit more about who's here and a little bit more about you. So just got 2 really quick questions on a poll, which is going to pop up on your screen here right now. So this poll should be popping up for you right now. First question being, just to see who's here, what role best describes your role at your organization? Are you a technician and or machine operator on the maintenance or operations side of your equipment? Are you a maintenance planner, scheduler? Are you a manager or supervisor of someone doing troubleshooting work? Are you an HR or training manager for your facility, a safety manager? Would you consider yourself an engineer, or are you other? And we got some responses coming in. Again, you can just click the answer to register your answer. And then second question is, how often do you troubleshoot machines or equipment on your job? Is it very often? Is it occasionally? Is it rarely, or is it never? And we got some really good answers coming in here. All right, looks like the answers have evened off, so I'll go ahead and end the poll, and I'm going to share that result with you all right now. So you should see the results popping up on your screen. So far and away, 41% of you here are technicians and or operators. So you're the ones out there doing this work hands-on with the machines, trying to figure out issues on a regular basis. And indeed, answer to question number 2, the predominant answer being absolutely, very often, all the time, right? We have to troubleshoot machines and equipment, maybe even on a daily or hourly basis in some cases. So troubleshooting is that fundamental skill that really is the bedrock for any of these technical trades, right? Whether it be plumbers, electricians, maintenance technicians, mechanics, all the way up and down the trades. This is really an essential skill. And so what TPC tends to do is we try to open up people into the career by starting with a troubleshooting workshop. And what we're going to talk about today is just a little tidbit of what we start getting into during these troubleshooting essential workshops or electrical troubleshooting workshops. And so if you see the window in front of you, you can go ahead and just close that window of the poll and get back to our presentation, and we'll go ahead and get started. So troubleshooting, right? Troubleshooting. It is a term you're going to hear a lot uh, out there on the floor. It's, dealing with trouble. But in another way, if you think of it this way, it's really solving problems, right? What is the method you can follow to solve a problem? Well, it's obviously important to figure out what the problem is and then how to identify the problem quickly. So, what types of jobs might require this troubleshooting approach we're going to be talking about? Essentially, anyone who's out there in the technical fields, right, that are the ones we're really focused on. Maintenance technicians, right? Whether you're working on the equipment or on facility level stuff like boilers or air conditioners, right? Electrical, mechanical, really, it's across the board troubleshooting skills. Machine operators, so whether you're running machines or equipment, sometimes you don't always have to call over maintenance technicians. You're actually going to be running the machines yourself. So operators who have great troubleshooting skills end up being the best operators, because when something doesn't quite sound right or doesn't quite feel right with the machines they're running, they know what to do about it. Plant management, right? So if you're out there on the floor and you're looking at more of a process level, there's troubleshooting involved there. And in engineering, so many of you are engineers on this call as well, and that's really going to speak to dealing with process improvements and what's going wrong out there in a certain process and how to brainstorm ideas for making it better. But really, at the end of the day, isn't everyone doing troubleshooting in some form or fashion in their jobs? Even if you're in a pseudo office environment, right, where you might not even be in a manufacturing or production based environment, everyone's got to troubleshoot in their own way in terms of solving problems to help make your workplace better or more efficient. So really, troubleshooting in the methods we're talking about are pretty fundamental. And putting this in another cross section kind of thing is the type of equipment that might require troubleshooting, right? So definitely equipment that's, let's say, motors, pumps, and blowers. So electromechanical equipment that you need to take apart and try to figure out what's going on. Or you can maybe look upstream of this stuff and look into the electrical controls for these pieces of equipment. Buildings or building automation systems, PLC systems, for instance. What else? Process specific equipment. So maybe maybe process equipment, like what we mean by that is heating equipment, like hot water boiler, steam operation, uh, all the different types of certain operations might have electrical and mechanical, but they might also have chemicals coming in. They might have hot water, cold water. They might have compressed air, pneumatic systems, hydraulic systems, all sorts of different things coming into one place and trying to understand them. Variable frequency drives. We find that if you're trying to run these motors, pumps, and blowers at different speeds, understanding how to troubleshoot variable frequency drives. Emergency generators as well. So if the power goes out, you got to figure out how to switch over to those generators quickly. And if the generators aren't kicking on, now we're dealing with not only just electrical and mechanical, but also engines and fuel systems and cooling systems and lubrication systems, all to go along with that. Again, mechanicals like pumps, bearings, vibration, all that kind of fun stuff on hydraulic and pneumatic, and air conditioning systems. So really, this slide is where I want to spend most of my time in kind of covering that logical, systematic approach to troubleshooting. This will just take a few minutes of our time, and this will be a really, hopefully, just good session to give a tidbit of how we create a fundamental troubleshooting approach out there on the floor. In describing each of these steps, what I'll do in this case is really set up a scenario here. And that scenario is, let's say, depending on your role, we all have different roles here coming to the table here, but let's put ourselves in the shoes of a maintenance technician, someone who's going to be responsible for fixing a machine out there in a facility, right? Whatever that machine might be, whether it's a plastic extrusion machine, whether it's a mechanically operated conveying machine, let's say, or maybe just a big boiler or steam operation, right? Now, let's say the operator of that machine comes up to you as a maintenance technician and says, hey, my machine won't turn on, fix it, right? And I'd like to kind of have anyone reflect on any time that has happened where someone walks up to you and just says, it's not working, you need to fix it. And that's pretty much all the information you're left with to start your troubleshooting process. Right? That's kind of, let's say we're walking in the door to this process from the get-go. What do we do first? What is step one of a troubleshooting process? Well, there are a few different frameworks to follow, but our framework really starts with, before you start digging into the electrical panel or taking stuff apart, it's really important is step number one to actually confirm that something is wrong with the equipment or the machinery. So based on your knowledge, this is where kind of your background knowledge and understanding of the process comes into play, where, okay, how should it work? And basically confirming that if when you try to run it in the way that it's supposed to be run, there's actually something wrong, right? So once you confirm that, that's a fairly quick process. What do you do next, right? Something that we try to talk about in our classes here at TPC is try not to dismiss that operator out of hand and just kind of try to troubleshoot on your own, right? The best troubleshooting process is a team effort, right? Not only with you and other maintenance technicians, but between maintenance and machine operators, or between supervisors, the safety and training managers, and the machine operators. People have different skills that they can bring to the table and can really help brainstorm the different ways to fix a problem. So um, before dismissing that operator out of hand, step two really becomes asking the right questions of that machine operator and the people who know how the machine should work. Asking questions, right? That is an art, in fact. There really is an art to asking the right questions as a maintenance technician. And what I mean by that is yes or no questions, right? If you say, did you do this? Yes. Did you do that? No. Those are okay, but really they're not the best type of questions. The best type of questions to ask, and we're going to get to this a little bit later in terms of the types of questions to ask, but who, what, why, where, and when. Those open-ended types of questions, we call them. What happened? What did you hear? Right? How did it happen? When did it happen exactly? So that gives the operator not just shaking their head up and down or left and right. They'll be able to describe in detail what they experienced that led to this issue. Maybe they're hearing a loud humming noise and it's kind of a weird grinding noise, but it's not working. Or they're seeing a red light flashing, or something like that that will help narrow down the list of things that could be wrong. Really, the whole thing about troubleshooting out there on the floor is trying to create a long list of things that could be wrong and narrowing that down to a shorter and shorter and shorter list of things that could be wrong with the machine or equipment. And so asking those right questions. Who else saw what happened, right? What happened? Where did it happen? How did it happen? All that kind of stuff. Then once you get everything you can in terms of data, I guess, and downloading from the operator or who was around when the issue started happening, now it's time to use your own senses, right? Troubleshooting definitely involves the use of tools, which we're going to be getting into, like meters and measurement equipment. But before we kind of get into that whole process, you can actually find out in a lot of times, you can really find out what the issue is just by using your eyes and your ears, and even your sense of smell in some cases, and your sense of touch in some cases, to figure out what's going wrong without having to suit up and without having to do a bunch of the other stuff. So are you hearing anything, right? So when it comes to electrical and mechanical equipment, for instance, particularly electrical equipment, if you can hear the humming of a motor, if you can hear the buzzing of or movement or heat in certain equipment, electrical current is getting to that equipment because you can hear it running or trying to turn over. And that really helps on the electrical side for troubleshooting. Are you hearing a buzzing noise? Are you hearing humming? Is something feeling hot to the touch, right? That really is an indication of what might be happening. Maybe bearings are bad. Maybe there's extra friction. Maybe wires are loose, causing some of this arcing to occur. Really, these senses are helpful. The eyes, right? If you're seeing some discoloration in a certain part of the process, that can help direct your attention. Now, let's say your senses start failing you. This is where other tools start coming into play. So if you can't see what the issue is, it's everything looks normal, everything sounds like it should be normal, everything feels normal. What's next? Well, this is where you got to really start preparing yourself for some more troubleshooting on stuff that you can't see. Like in the case of electricity, um, using that multimeter to poke around and try to figure out for yourself what's happening. And in that case, you're going to have to start tearing apart the equipment, opening panels, doors to start doing some troubleshooting. And that's really the first step you need for any good troubleshooting process from here on out. Whether it is mechanical or electrical troubleshooting, is getting your proper PPE for the job. So, um, in the mechanical world, that's the proper gloves, proper guarding, proper lockout tagout procedures before you start digging into equipment and taking a look. On the electrical side, it also involves lockout tagout, but on the electrical side, making sure if you're going to be just looking at stuff and visually inspecting, um, or if you're doing live voltage troubleshooting, lockout tagout won't be part of it this time, but wearing full body arc flash PPE for the electrical part of this equipment, and knowing that comes with a whole set of knowledge and skills with electrical troubleshooting and understanding arc flash PPE and protection. Just to let everyone know, some people are using the chat line. Totally, I understand that, but make sure that on the Q&A line is the one we'll be monitoring for questions. So gathering your PPE, and then once you have your PPE, you know what it's going to take to protect yourself, and as you begin to troubleshoot, getting the prints and the documentation as well. So basically, let's see. Basically, yeah, just want to make sure everyone can hear me. It looks like everyone can hear me fine. So someone was having some issues there, but yeah, just let me know if anything gets to be too bad there. The prints and the documentation. Good documentation, particularly the schematics, the wiring diagrams, the ladder diagrams for controls are so important when it comes to troubleshooting. In fact, in our coursework, we really talk about how the proper prints and proper documentation, in fact, are one of two most important tools for any troubleshooter. The schematics are number one, and number two is that meter, that testing device. Really, that's really what we talk about here in troubleshooting. Hammers, uh, wrenches, those kind of hand tools are great tools for certain occasions, but for any occasion, when you're troubleshooting, having good prints and documentation and having a good meter are the ways to go. So if you think about it this way, both of those tools can have different levels of quality, right? So if you, on the meter side of things, whether on the mechanical side, you're going to be doing some vibration analysis or looking at infrared or heat, or on the electrical side, you're going to be testing voltage or current or resistance. The quality of that meter matters. There is a thing called a category of an electrical meter that's super important for electrical troubleshooters to know, that the category, whether it be category 1 all the way up to category 4, is proper. And we talk about that more in depth in some of our electrical troubleshooting courses on making sure you have the right category, right voltage rating, and proper listing by a third party to make that work. So thank you all for weighing in on some of the audio. I really appreciate it. So on the print side, another thing and something to be very aware of is, especially if you're on the electrical side, NFPA 70E, which is our electrical troubleshooting standard, and then our electrical arc flash safety standard, says that facilities must have up-to-date prints and documentation of their one-line diagrams and their facility level diagrams. And what tends to happen is if those drawings are not up to date, you could actually get in some trouble with safety, because that's how important these documentations are. Not only that, but if your schematics for your specific machines are out of date for any other reason, you could actually be facing some serious risk. Think about it. If your maintenance technicians are looking at a schematic and expecting, let's say, 2 relays to be there and a motor starter for this machine, and they open the door and they see 5 relays and 4 motor starters, right? That they replaced equipment since the last go around of that drawing. Now that person really doesn't know what wire connects to what anymore and what readings they should be getting from where. So I think it's going to be a really important distinction to say you have to have up-to-date schematics and really good quality meters. Not something you might buy off of, just a random wholesale warehouse, but a really good quality, reputable meter. Okay. So once you got all that, you're all suited up in the PPE. Now it's time to really take that approach inside the panel. Okay. And that comes into the testing incoming and testing outgoing. So on the electrical side, it's voltage. Typically, if you're troubleshooting, you're going to be testing at the beginning and testing at the end, and making sure that the voltage or pressure signal that you're getting in the troubleshooting process is there. That basically, the operation is there at the beginning of the circuit, and the operation is there at the end of the circuit. Right? And then from there, what do? Well, we if we know it was there at the beginning and it wasn't there at the end, whether it be the voltage we're looking for or the pressure we're looking for in the case of, let's say, water flowing or a pneumatic or hydraulic system, then we start in the middle. We basically try to split the whole system based on what we're seeing in the schematic in workable pieces. One smart way is just cutting it directly in half. Start somewhere in the middle and see if you get what you'd expect in the middle, and then if that's working, now you have it cut into that first half of the circuit versus the second half. And really, this is where systematic, slow but steady movement of your metering device through the system to test that pressure or that voltage or that issue, right? And just trying out the different testing to get to where you need to go. And before you know it, right, you'll find the problem device and you'll find the issue you need. Now, obviously, going from step 8 to step 9, I made it seem easier or whatever, but it's obviously, this is the hardest part about troubleshooting, is finding that one problem thing, whether it be a wire or a valve or um, a just some sort of gasket or some sort of fitting or some sort of connection that's gone bad in a huge complex piece of machinery. This is where troubleshooting takes practice, and there's really no substitution for getting that practice on the job of troubleshooting. Our courses are designed to give a lot of great practice in a 2-day workshop. However, you got to couple that with on-the-job training with a good mentor. Find someone out there on the floor that really has been doing this job for a number of years, months. Identify the person who also knows how to show you around and can show you the ropes. Value those people with such a high degree, because those people mentoring you and showing you around are the people you learn the troubleshooting job from at the end of the day. Having a good trainer, mentor in the maintenance or operator trade is just worth its weight in gold by figuring out how to start in the middle and then finding that problem and device. Once you find the problem or the bad device, right, what are we going to do from here, right? Well, let's say in the case of an electrical circuit, it turns out a relay. I narrowed it down to a relay. That's bad. Okay. So I pull out the relay, and then what do, right? Well, you might feel inclined, and definitely many departments feel inclined to say, all right, pull out the relay and just put in a new relay, and let's just get back into action, right? Get back into production. Our downtime is ticking and clicking. Absolutely, someone indicated test the bad device before you replace it. What if you were just, we're all human. What if you thought you had narrowed it down to the coil of the relay, but turns out the relay was in perfect operating condition, and the reason you got the bad test is because the wire coming into the relay was bad or something like that. So test the device itself. Whoops, I skipped forward a bit. Remove that device and test the device with your meter. So in the electrical case, right, you can test with ohms of resistance and test across that device and make sure it gets what the manufacturer specification is for that device across either a contact or that coil. Um, any mechanical electrical device can be tested according to its manufacturer specifications. And then once you verify, okay, yep, this is absolutely not working the way it should, now we can go ahead and replace and repair that device. As you can probably imagine, there's space here under step 12, so there is more after replacing and repairing the device. And this is all kind of the part of tying it up in a nice little bow type of part of the process that a lot of people doing troubleshooting forget about, right? And you got to make it as part of your routine to do some of this um, back end stuff as part of the troubleshooting process to be a good quality technician or operator or even supervisor. And that was so replace and repair the device, but then without further ado anyway, confirm the system's working correctly for that operator before you call them back. So you're going to see all these steps here up on the screen here all together here in just a moment. But confirm the system is working correctly. So yeah, you replace that relay and you're fairly confident it's going to work, but make sure it does before you give it back to whoever you're troubleshooting for. So turn it on, make sure it's running up to the specs that it needs to run and that it runs sufficiently for a period of time before handing it out. But then, right, that one device, we're either one device short in the warehouse or we've basically have ordered that we just don't have that device anymore now that we've used it to replace. So it's really important to replenish your supply of either your parts storage or your warehouse area to order that new device, replenish the stock, make sure that you don't end up putting the next technician, let's say weeks or years from now, in this predicament where they can't fix this issue because they don't have the part. And then finally, any good technician and troubleshooter must document. Okay, complete the documentation of the process that you followed for the troubleshooting process, and that means filling out and completing the work order for the process, saying exactly what you did to solve the problem, and filing that into some sort of central documentation system, whether it be a maintenance organization system or in some sort of central file sharing system. Because if a technician comes around and let's say they find out next week that that same component is bad, right? They can look and say, oh, wow, uh, you know, Ryan fixed that component last week, and then Ryan's coworker fixed it the week before that, and we're starting to get a more of a story of what's going on with our process. Maybe there's a bigger problem at play. Maybe we're overloading we have the proper rated devices, they're improper, or we're overloading the motor in many cases. When motors go bad more and more often than they should, these motors out here in your facilities, guys, more times than not, they have to last decades, right? Not just a year and then these motors go bad. Most motors are designed to operate 25 years plus in operation. So if your facility's finding that electrical motors are going bad every year, that's an indicator in and of itself. And completing documentation can really help tell that more complete story, and also keeping that documentation for periods of time. It's important. So here it is all laid out, right? Confirming there's something wrong, asking questions, using your senses, gathering your PPE, getting the prints and documentation. And I will say, and this is we're going to kind of dig into between basically steps 1 and 6, between confirming that there's something wrong and getting your test implementation out and doing testing. Because what are in between the lines here is, when you open that panel for the first time, you are putting yourself in significant harm's way. Or in the case of mechanical troubleshooting, if you're opening um, machine guards in some sort of way and putting yourself in front of potentially rotating equipment, you're putting yourself in harm's way of getting an injury. So you want to try to minimize the amount of time that you're in the environment of putting yourself in harm's way, whether it's an arc flash that could happen or some sort of pinch or cut that you could get in mechanical troubleshooting. So it's really important to have a short list of things that could be wrong with potentially wrong based on what you're seeing with your senses and the questions you asked before getting into these panels. How do we get that short list of stuff that could be wrong, right? Let's say you're a technician, right? Let's say it's your fourth month on the job, right? That's fairly new as far as maintenance technicians go. You've been on the job for 4 months. Someone of a, let's say, plastic extrusion machine says, hey, my machine's not starting up properly, help, right? That operator, first and foremost, is, like we talked about, the expert in that equipment. Pick their brain about it, but also the more voices you can get at the table, the more perspectives you can get to get that short list, the better. So brainstorming is what I'm getting at here, guys. The more people you can get into your brainstorm to help get you that short list of things that could be wrong before you have to get in harm's way, the better. Troubleshooting is a dangerous process, and making sure you can brainstorm with others. A lot of companies actually rely on having meetings to do troubleshooting, right? I know many of us in the technical trades just cringe at the idea of meetings, but at the very least, having a stand up, right, in the break room or in the manager's office to just sit there on a whiteboard or a sheet of paper and just write out all the things that could be wrong with this machine and why, right? Sometimes it's hydraulic issues. Sometimes it could be pneumatic issues. Sometimes it could be human error. We all know that, operator error. But there could be a lot of other issues at play, including issues with the whole facility at large. So it's really important to try to get a narrow list of things that could be wrong. And then when you're in the panel, now you have a really quick action plan. Okay, one of our things on the list was that we don't have power to the panel. Well, boom, I can verify that now. From going from line 1 to neutral, I can verify whether that's true or not. Okay, cross that off the list. Now, during our brainstorming session, we also said that, the wiring going to the motor starter could be bad. And then I'm going to start testing that, so on and so forth. So brainstorm with people. It's a team effort. Do not be afraid to work with other people, get other perspectives at the table, and minimize that amount of time you are in the panel. And document, document, document. I know maintenance technicians don't like writing things down. They think it's kind of just, I need to be out on the floor. I'm a hands-on person. I'm not here to do office work. Just know that documentation is essential for any technician role. Here's another way to cross-cut the troubleshooting process, and that is the 3 stages of troubleshooting. So let me just lay this all out in front of you. There's 3 steps of this, and that is investigating the problem. We kind of talked about that in terms of asking the right questions, getting that list of things that could be wrong, potential symptoms, and really finding out through those questions whether there's been any changes to the system that might be causing the issue. Analysis of the potential issues. So this is where brainstorming's coming into play some more. What are the most likely causes, right? Based on our experience, and then time to test those possible causes. That's where getting the meter out comes into play. And then implementation is what I would say is not necessarily troubleshooting anymore, but it's that tying it up with a bow part of the process, which is repairing the problem, verifying the fix of the problem, and documenting the problem. Document, document, document. This is kind of the 3-tiered approach that we can follow as well. We talked about questions, and again, questions being absolutely essential to asking the right kinds of questions. And here's just an example for anyone's benefit. And this is really the last thing I just want to chat about before we open the floor for questions. Then we'll be all set for today. So what are some good questions to ask, right? Here's one. What were you trying to do, right? Hey, my machine's not working. Help. Okay. What were you trying to do, right? Were you trying to start it up? Were you trying to set it into maintenance mode? What were you trying to do, right? That really helps indicate where to start. What did you see and hear, right? So that, let them be your eyes and ears. If you weren't there when the issue happened, let them describe the issue as they understand it. Again, machine operators, I had a great discussion with some machine operators recently where they said, you know what, I've been working on this machine for so long that I know the way it hums, right? And if it hums just in a slightly different pitch, I know there's something wrong with my machine. And that's really how well tuned these operators are to their machines, that the technician can really learn a lot as they try to troubleshoot while it's down. When did it happen, right? Or how often, right? Does it happen? Is it happening every day? Has this happened before, right? Does it happen in the morning of every shift, or maybe, after an hour of operation, then it happens, like, which might indicate some sort of overheating issue? All this type of stuff is important data for the technician. What changed with the system recently? And typically these changes, whether, we're in a highly flexible environment where we're always making changes to these processes for different customers, that's really where troubleshooting gets to be tricky, because we don't know what changes have been made recently, and it's good to document and make sure you know what changes have been made. And then finally, like we talked about, try to avoid those yes or no questions. The more detail you can get out of the operator, and the more you can listen, right? Listening is so important. Let them describe while you just let them express what has happened. And then important to write down your answers. Write down everything they're saying. There's a lot of information. The more you write down, the better equipped you are to try to cross off what could be the issue and start narrowing down the list. Okay, so basically that is the meat and potatoes of what I wanted to just cover. Again, this is a free public event where we can just kind of set the stage for the troubleshooting, the essentials everyone needs for troubleshooting: asking good questions, the step-by-step process. And you think about it, right? A machine, which we're definitely focused on in the scenario we talked about today. But you can see how this can be followed if you're having an issue with your car, right? Or if you're having an issue even amongst some sort of workforce or interpersonal issue, like management type of issue. Okay, what's the problem? What happened? Let's try to get a list of 3 things that could be wrong with, let's say, I don't know, the training that we had recently, or the perception of efficiency across the company, or how our communication is across our company. Even these personal issues, you can still start with, all right, what happened? What should be happening? What would you like to see happen? Okay, and then what is the short list of things that could be causing this breakdown in the process? Let's try to figure it out from here. This can be done at the engineering level, and I'm sure it. Again, engineers kind of have a reputation for working by themselves in a little cubicle, working on something and not really being people persons. But man, the best engineering process always involves a team, always involves working with and troubleshooting issues in larger processes in general with other people. So don't be afraid to get other people involved in the troubleshooting and the brainstorming, and always document the brainstorming. Okay. So if you want to learn more about troubleshooting, I mean, troubleshooting is the backbone of everything TPC does, in fact, in our customers, like you folks, who are essential to the workforce of troubleshooting, mechanical trades, technicians, mechanics, whether you're working on aircraft or machines or facilities like, boilers and steam systems and all that fun stuff. So there's a lot to talk about here. And this is just the tip of the iceberg, but really everything comes from this skill set, as in the trades, right? Troubleshooting skills, um, approaching it in the right way, no matter what job you're dealing with. So we got, what I'm going to do now is switch over to the question and answer line, and really just let you all know, as you can see here. Hope I can get to all the questions here. We got a nice amount coming in, and feel free to continue typing questions in the Q&A line, and I'll try to address as many as I can before we close up shop today. And really what I'd like to say is continue the discussion even after this event by using this email address, our sales@tpctraining.com email address, to talk with us some more. You can get connected with me through that email address, or you can call our phone line, 847-808-4000, and continued that discussion with one of our client service representatives, me, any of our instructors, really, whoever you want to talk to about some of these issues you're having in your facility. We can help weigh in on ways we can get you what you need in terms of getting those troubleshooting skills in house for you. So someone indicated, yeah, I'll ask if there's power, right? That's a great point. It's always important to say, is there even power to this machine? Maybe we just lost power. Maybe our circuit breaker tripped, for instance. That's an important and fairly common issue, is something as basic as the e-stop has been pushed on accident, or the circuit breaker has tripped. However, I want to say, in response to the idea of there being power, if you go to a panel and you open the door and you indicate absolutely there's 0 volts in there, from phase to phase and phase to ground, we don't have power, right? And you go over to the circuit breaker panel and you find indeed that the circuit breaker has tripped, I want you to resist the urge of flipping back up the circuit breaker and then turning everything on. Okay, we're fixed, right? Something caused that circuit breaker to trip. And that's really the issue here, is that sometimes there's a root cause analysis that needs to happen behind troubleshooting. And that is, okay, we didn't have power. Why didn't we have power? Because the circuit breaker tripped. Now you can kind of act like a 3-year-old at this point and say, okay, why wasn't there power? And keep asking why as far as you can. In fact, there's an official documentation of this process. It's called the 5 why analysis, you may have heard about. Continue asking five layers of why behind every time you answer the question. See how deep you can get into terms of the root cause analysis. So there was no, so why is this machine not working? Why? Because there's no power. Okay, why is there no power into the panel? Oh, because the circuit breaker tripped. Okay, why did the circuit breaker trip? Oh, because it exceeded its amp rating of 15 amps. Oh, why did the circuit breaker exceed its amp rating of 15 amps? Oh, it's because we were asking the motor that's running that machine to run 17 amps. Well, why are we running the motor at 17 amps, and so on and so forth? And turns out, oh, we actually tried to increase beyond 100% operation on this machine because we're trying to meet new production quotas. Oh, and now this is speaking to the real issue behind it, and that is, okay, maybe we're either A, undersized our motor now for our new production quotas, or B, we need to slow down our production quotas, right? And that becomes a whole other issue at play, but it really helps dig deeper into the issue. So um, let's see, what other kinds of questions are we getting? So thank you for those great questions. Um, when should I wear gloves to protect myself against electrical shock and injury? That's a really good question. Thank you for that. In terms of the PPE and protection of some of this stuff. So gloves, electrical arc rated and voltage rated protective gloves have to be worn anytime you are facing the risk of an electrical shock, right? According to NFPA 70E. Now, when are we facing a risk of electrical shock? Anytime you are faced with exposed energized electrical parts, right? And then you kind of ask a bit further, okay, when am I going to be in front of exposed energized electrical parts? Well, anytime you open a panel door for any reason, um, in that or even so, the panel door is not secure and closed, um, and completely guarded at all times. So basically, anytime you're doing troubleshooting is what I mean by that. You need to wear those electrical gloves. So anytime you're going to be doing, voltage testing, anytime if you're just opening the door just to look and just to get a visual inspection, even if you're not touching, you still need to wear those gloves. The next question might be, okay, what type of gloves do I need to wear? It has to match the voltage rating. Usually class 0 gloves are standard for anything, at 480 volt level, which it has the red label on those gloves, class 0 rated for 1,000 volts of usage. But it really depends on the application. So just be careful of that. Why is it not a good idea to measure resistance on a live circuit? Another great question. So ohms, right? Measuring ohms is actually, first and foremost, it's not accurate to measure ohms in a live circuit, because ohm readings are are basically inherent to any object, no matter whether they're in a live circuit or not. They're inherent to every object. So once something's live with energized electrical circuit, energy and current, the reading of ohms is not going to be accurate because of all the movement of the electrons in there. In fact, the best way to measure resistance is to pull that device out of the circuit and onto a table. And so there's no electrons flowing, no voltage potential, no electrical charge built up in that device. So in the case of capacitors in any sort of energy storage, you got to make sure to dissipate any voltage potential. And then you can test with ohms on your meter. That's the best, most accurate, and foolproof way to measure resistance. In fact, right, if you try to measure resistance and it's live, you could actually blow the fuse inside the meter, or better yet, in a lot of cases, the ohm reading is not fused at all. So where you could just blow up your meter because there's not a fuse on the resistance part of the meter, and it could blow up in your hands. If anyone has seen videos or experienced firsthand an electrical multimeter blowing up, it can really have the impact of a bomb going off in your hand. It really can. And so people have gotten seriously hurt and even killed, disfigured from meters blowing up. These are the only things between you and that intense amount of energy inside some of these 480 volt circuits. So that's the reason why we shouldn't test resistance. It could actually lead to a severe failure of the meter, and at the worst and at the best, very inaccurate readings on the meter that aren't really giving you a good idea anyway. So hopefully you all got the good steps there on this troubleshooting approach. And again, this will be available for those of you who missed any tidbit here. You can watch back the recording, and you can call us at this number to get even more in depth with some of the talks. We love talking to you about troubleshooting. That's what we do. That's TPC. All of our courses revolve around troubleshooting skills. So let's see. What do you mean starting in the middle? Great question. So in the case of an electrical circuit, right, you have the hot line coming in, or what we call the high potential live voltage coming in. And then that voltage feeds its way all the way through a series of complicated circuits. It's got to go through push buttons. It's got to go through limit switches. It's got to go through selector switches and the red buttons and the green buttons and light bulbs and all that sort of stuff, right? So if you know that all that electrical current and the voltage potential of that electrical current is making its way to the very input of the panel, at least the panel is energized with that electrical potential. And then you find that where you need the potential, let's say right at the input of one of those red lights, the potential is not there, right? What you've done is basically narrowed down that, okay, if the potential is not there at the light, the issue is not at the light bulb that you're trying to turn on, or let's say the motor starter you're trying to turn on, or later, which could be anywhere on the neutral side past that. That's most likely, not necessarily guaranteed, but most likely not the issue. So then you can start tracing your way back. You basically cut the circuit in half. Now let's talk about it in another way. Let's say you tested voltage coming in, and then you tested again the voltage right at the light, and there was still voltage, or let's say right at the motor starter, and there was still voltage, but the motor starter's not kicking in, or the light's not coming on. Now that could be an indication of the second half of the circuit, either the light bulb itself or the neutral. Something might be going wrong with the neutral. So there's a bunch of different ways to indicate these issues. And then obviously bad neutrals give the weirdest electrical readings, and we get more into that in electrical troubleshooting courses. By the way, I just wanted to kind of let you all know that getting practice on electrical troubleshooting, it's hard because electrical troubleshooting, is done at 480 volts and 120 volts in many cases. And some of us are lucky enough to have 24 volt control circuits. But if you're troubleshooting on 480 volt motor starters, for instance, that's some dangerous work that you don't really get a chance to do if you're new to the field of troubleshooting. In that case, I can't recommend more the idea of simulating the troubleshooting experience, right? Um, go in front of a simulated environment where there's a whole panel in this environment, and you can pretend to put your meter leads in the simulated environment, whether it be, let's say, virtual reality or on your computer, where you can, okay, I'm going to drag my leads to this huge panel. I'm going to go to line 1. I'm going to go over to this light bulb here and see what the voltage readings get. There's simulators out there that are available. TPC has one called Simutech, where you can do, controlling control circuits with relays, motor starters, and the motor doesn't come on, and you got to try to figure out what's going on based on what you're hearing and what you're seeing from your meter readings, for instance. It's important to be able to have the ability to do this stuff in a safe environment, or in the classroom where the voltage has been stepped down to a low enough level that you don't have to worry about your safety. Okay. Yeah, the good point about 3-phase breakers with the A phase. So if there's any phase unbalance on a breaker where one of the phases are just not operating properly, that could cause a trip in a breaker. Absolutely. We've got some really great questions flowing in. Let's see. I only got 10 minutes maximum about this, and let's see if I can help answer some of these. Is it beneficial to train the operator on how to use on how a unit works and things they can be aware of? Um, Definitely. Yeah. So operators got to be properly trained. Absolutely. On this kind of stuff. Oh, here's a really good point. And this gets to some deeper issues behind a troubleshooting process. And that is, how do you encourage people to complete the documentation or the recording of a troubleshooting job? Right? Like we said, we in the maintenance trades, in the technical trades, we sometimes resist, I'll put it that way, resist writing things down, because that's not our job, right? That's the office people's job. I don't want to sit in front of a computer and type things out or write things out. Um, and this individual in particular is having difficulties motivating others to see the importance of records. Um, it really, unfortunately, that pain point gets experienced only through experience. So that person will say, "All right, when was the last time this was fixed?" And then when the response becomes, "Well, I don't know, because you haven't been writing it down at any time." "Oh, well, I think I remember 5 or 6 months ago doing this, but I don't remember what the details were." I hope they can see the benefit of, like, okay, now we're kind of struggling here for no reason. If this was available, we could have just looked at it and moved forward. So as long as it can be related back to their job effectiveness and their job efficiency, so they don't have to work as hard, right? They can work smarter, not harder type of mentality. That's, I think, really what speaks most to technicians that I've met who are resistant to documenting things. It can be, it's just it's going to make your job easier, even though it might take 10 extra minutes at the end of each individual job. You're going to be so glad you did it when it's the 10th time you've done it, and you need to know what's really behind this issue in terms of repeated fixes and repeated repairs. So troubleshooting courses. Thank you, Travis, for this question. So troubleshooting courses, right? Essentially, Travis, all of our courses at TPC are centered around troubleshooting. I can't really narrow one down, but I guess I would say that our feeder course, our basically intro 0 level course, is called Troubleshooting Essentials. It's taking what I just talked to you here, guys, give you a free little tidbit of, and build upon that by doing workshops and scenarios around different scenarios, and seeing if we can find what the issue is around those scenarios. Real world scenarios we're running everyone through, doing some real brainstorming in the class and on mechanical systems, hydraulic systems, electrical control systems, motor based systems, etc. And absolutely every single class we offer is also offered virtually as well as in the classroom. So just like this format you see here in this webinar, except for we all can see and hear each other through video chat. And so that's the way it is nowadays. And it isn't just sitting and listening to someone talk, even though that's exactly what you're doing now, unfortunately, but that's the only way we can get all you people in on this live event. But in a classroom, it's more like, 5, 10, 15 people at a time, where we can all interact with each other and ask questions and discussion. Not only that, you're launched some real hands-on So it's not truly hands-on, obviously, through the virtual environment, but it's a simulated environment of an electrical troubleshooting job. Okay, now see this panel in front of you. Time to test the different ports and let me know what you think, right? You can either, you got to put on your PPE equipment virtually through this exercise. You got to test the circuit the right way through these exercises. You got to find what the voltage level is in different areas through these exercises. So there's a lot more you can do in a virtual format than you give it credit for, especially in learning how to do troubleshooting, right? Someone confirms here, Robert, thank you. You listen to the operator or the person. It's so important. Uh, and let them talk. That this is this is so important. A lot of us, especially, can let our emotions come to the table where we say, "What the heck's wrong with you? You know, you broke it again. You know, it's got to be your fault as the operator. So just get out of the way. I'll fix it." Right? And you might feel frustrated with the operator for breaking their machine for the 10th time this month or whatever it might be, but let them talk, let them express what's wrong with the machine in as much detail, and try to listen and not interrupt them. I couldn't agree more with that statement. Let's see, got some other couple great questions. Again, I wish I could get to all these, but I only have just about 2 to 3 more minutes left, and I want to honor your hour commitment here for being together. So thank you all for being here. Let's see. Um, Hydraulics. So someone says, electrical schematics are well and good in the meter, but hydraulics is harder to understand the schematic. Do you have training for hydraulics? Yep, we sure do. Hydraulics is part of our portfolio here. So there's ways to understand hydraulics in a bunch of different ways, but those diagrams where you can kind of see the valves and where the pressurized flow versus the exhaust flow versus the metered flow in a hydraulic system, it's remarkably similar to electrical, but in its own mechanical way. So yeah, I highly recommend you look into getting more training there. Um, you know what? Someone talked about, troubleshooting might involve greasing of bearings, right? What is the recommended OEM's greasing of the bearing? And the only answer I can give you, I wish I could say, X amount of milliliters per month, but really it's all according to the manufacturer's recommendation. That's my cop-out answer, and that's always got to be the answer when it comes to greasing and lubrication issues. Um, Follow manufacturer's recommendations. They are going to have those recommendations, whether it be for bearings, or whether it be for a motor, or whether it be for a generator, or whatever it be. There's greasing requirements, and I can probably guarantee you that 9 times out of 10, you're going to think that it's less than what is really needed. I know we had staff at a facility I used to work at whose job was to go around on a weekly basis and just grease all of our machines until they saw the grease coming out the other side. And it turns out that's way over lubrication of those machines, and it could actually cause more hurt than good. And we talk more about proper lubrication techniques in our motors and control circuits classes and that kind of thing. When you get a repeater problem, isn't it a good idea to contact the manufacturer? Yeah, absolutely. Especially if it could be a defect with the equipment, obviously, or maybe we're just not using the equipment in the right way, or maybe we got the wrong size, wrong horsepower in the case of a motor. Absolutely, 100%. Good idea to get the manufacturer's weigh in on that. What's the best practice to discharge capacitors? I wish I could go into detail on that, Javier. Thank you for the question, but definitely not across a screwdriver, okay, guys? Or not as a prank to your coworkers and throw it to them and give them a little shock for a laugh. That could actually seriously injure or kill someone, especially if they have heart problems. So just don't do it that way. But there are rated power resistors that you can discharge capacitors through in a safe way, and they just dissipate it as heat, and then you're good to go. Okay. Electrical troubleshooting, there's a regular electrical troubleshooting, basics of electrical, advanced electrical troubleshooting courses out there. Definitely keep those in mind. And I think that's all the questions I can answer, unfortunately, for now. So I really appreciate you all for being here. Thank you so much for a great session. And again, look out for the recording for this session within about 2 business days of the end of this session. And feel free to reach out to us here for more curiosities, for more questions. If you want to chat with me, by all means, let's chat. Let's do it. We always look forward to hearing about how it's going out there in the field. So thank you again for your time and have a great day.